Hey Geometry Geniuses, we're going to take a look at 6.6, jumping ahead a few sections or so on trapezoids and kites. Our goal is going to be finding and using properties of kites and trapezoids. In the quadrilateral families, we saw some of these characteristics before, where parallelograms have two pairs of parallel sides. The opposite sides run parallel, and they're also congruent. With the trapezoid, we only have one pair of parallel sides. Notice how the sides here are not parallel. If these continued, they would intersect. And with the kite, these don't have any parallel sides. At some point, this side intersects this side and then intersects the others. So those characteristics are important. As we move forward with parts of a trapezoid, the trapezoid is considered a quadrilateral, so a four-sided figure with exactly one pair of parallel sides. I just told you this. We say that it has four base angles, two up top, two in the bottom. We'll refer to the top part as a base and the bottom part as a base, and the side portions are legs, bouncing off of what we saw with parallelograms. These angles are consecutive and are complementary, so they add up to 180. On all trapezoids, the angles on the same leg are supplementary. We already saw this. So this is just continuing with angles that are pretty much side to side, even if they're a little bit farther down the road, as being consecutive. With an isosceles trapezoid, this deals with when both of the side legs are congruent. The angles still hold true, so we may come across an isosceles trapezoid if both of the legs are congruent. In this example seen here, using the idea of an isosceles trapezoid, if we had angle A at 95 degrees, then angle B would have to be congruent to that. So we could say that this would also have to be 95 degrees. If we were continuing with this, if we're looking at D, D should be congruent to C, because again, we're dealing with an isosceles trapezoid specifically, so this should also be 64 degrees. But if we were talking about angle D, and we were trying to find angle A, these two have to be supplementary. So if we did 180 minus that 53, angle A would have to be 127. So this only really works if we're dealing with an isosceles trapezoid in particular. If we continue with the midsegment of a trapezoid, this is as if it is running parallel to both bases, and that length is half the sum of the bases. So in this example here, we have a top base of 6, we have a bottom base of 8, so this midsegment here, dividing both of these legs in half, would be the average of the two. 6 plus 18 gets us 14. 14 over 2 gets us 7. So that makes sense that this midsegment here is the average of the two bases. A quick example seen here. If we have a top base of 12 and we're trying to find the midsegment for this trapezoid of x, our bottom base is 18. Well, I know that it jumps collectively from 12 to 18, 6 units. So I can assume that from the top base to the middle base, or the midsegment, it's as if we should be adding 3. And then if we do that again, we add 3. So in this case, x equals 12 plus that 3, so x equals 15. So this is one approach you can take, but if you wanted to go the other approach, you could have done x equals 12 plus 18 over 2, which would be 30 over 2, which is still 15. So notice we have two approaches. I visually scaled this up because I knew it had to be in between 12 and 18. With this one, with a little bit of algebra, we have the 2x plus 1, and we know that if we add on that 24, and divide that by 2, should be equal to 18. So now we're trying to think what x could be. So if we simplify this, multiplying both sides by 2, we get 2x plus that 1 plus that 24 equals the product of 2 and 18, so this would be 36. If we keep simplifying away, 2x will be equal to the difference here. So if we subtract 25 from 36, that gets us 11. So this is going to say that x is going to be equal to 11 halves. Which makes sense, because if we plug this back in way up here, 2 times 11 halves plus 1 would get us 12. So this would be pretty much a top base of 12. If we add 6 to each of the previous segments, we get to that bottom part there. For properties of kites, these characteristics are here. They don't have parallel sides, the perpendiculars are diagonal, and they have exactly one pair of opposite angles that are congruent. So notice that this diagonal splits, so this top is congruent to this other angle. We see the diagonals are perpendicular to each other. We see a lot of angles that are bisected. And we'll see more examples of these in class. Thanks for watching.